Welcome to the Enterprise AI Leadership Series on my YouTube channel. Most organizations still view explainability as a technical feature delivered by data scientists and machine learning engineers. Historically, that made sense. Explainability was largely focused on understanding how a model arrived at a prediction. But enterprise AI is changing the nature of the problem. As AI becomes embedded into business processes, operational decisions, risk assessments, customer interactions, and compliance workflows, explainability is no longer confined to the model itself. It becomes an institutional requirement. The real question is not whether a model can produce an explanation. The real question is whether the enterprise can operationalize that explanation across thousands or even millions of decisions. Can the organization retrieve the evidence? Can it demonstrate accountability? Can it defend the decision months later during a regulatory review, audit, or legal challenge? This is why explainability is rapidly evolving from a data science concern into an enterprise architecture challenge. The architecture itself must become responsible for preserving trust, accountability, and transparency at scale. If you find these enterprise AI discussions valuable, you may consider subscribing to my YouTube channel for future deep dives on leadership, transformation, and AI execution. Every significant AI decision now creates an evidence obligation. When AI influences a loan approval, flags a suspicious transaction, prioritizes a customer complaint, or recommends a clinical action, organizations must be prepared to answer a series of fundamental questions. What exactly happened? Why did the system reach that conclusion? Which model version generated the output? Who was accountable for oversight? Were escalation rules triggered? Did a human reviewer intervene? Many organizations assume that if the model can generate an explanation, the problem has been solved. In reality, that is only the starting point. The much harder challenge is maintaining a complete chain of evidence that can be reconstructed long after the decision was made. Without that capability, explainability becomes temporary and fragile. With it, explainability becomes an institutional asset that supports accountability, compliance, and operational resilience. Not every AI use case carries the same level of risk. A recommendation engine suggesting content or a personalization algorithm selecting a marketing offer may not require extensive explanation infrastructure. However, the equation changes dramatically when AI begins influencing decisions that affect people, finances, regulatory obligations, or public trust. Consider underwriting decisions in banking, fraud investigations, workforce management, healthcare prioritization, pricing decisions, or regulatory compliance monitoring. In each of these domains, AI decisions can have significant consequences. Individuals may challenge outcomes. Regulators may request evidence. Auditors may require reconstruction of decision history. This creates a new operational reality. Explainability is no longer simply a technical capability. It becomes a legal, regulatory, and fiduciary obligation. The organizations that recognize this shift early are building the infrastructure required to support explainability before they encounter regulatory or reputational pressure. Enterprise explainability typically follows a predictable maturity journey. The first stage is model-level explainability. Organizations deploy interpretability techniques such as feature importance scores, SHAP values, or local explanations. These tools help data scientists understand model behavior. The second stage introduces system-level explainability. Decision metadata, model versions, and operational logs are captured and retained. This improves auditability, but often remains fragmented across multiple platforms. The third stage is where true enterprise maturity emerges. Here, explainability becomes an architectural capability rather than a model feature. Evidence retention, governance controls, escalation workflows, and audit retrieval become integrated components of the enterprise technology stack. At this stage, organizations stop treating explainability as a report generated after the fact. Instead, explainability becomes embedded into the operating fabric of the institution itself. To support this transition, leading enterprises are redesigning their AI architecture around a new set of foundational capabilities. Evidence vaults preserve critical decision records and explanation artifacts. Explainability service layers provide consistent explanations across different AI models and business units. Decision orchestration platforms apply governance checkpoints and escalation rules based on risk levels. Human review routing systems ensure that high-risk outputs receive meaningful oversight rather than automatic approval. And governance as code embeds compliance requirements directly into operational workflows. Taken together, these capabilities form an explainability architecture stack. What is important here is that explainability is no longer treated as an isolated function. It becomes a shared enterprise service, much like cybersecurity, observability, or identity management. The objective is not simply to explain decisions. The objective is to make those decisions defensible, auditable, and trustworthy. One of the most underestimated challenges in explainability is organizational alignment. Different stakeholders often have fundamentally different expectations. Legal teams focus on regulatory defensibility. Risk teams prioritize audit readiness. Data scientists emphasize interpretability and model transparency. Engineers focus on performance, latency, and scalability. Product teams prioritize user experience and adoption. Each group believes it is addressing explainability, yet they are often solving different problems. The result is what many organizations unknowingly create: explainability theater. Explanations exist, dashboards exist, documentation exists, but institutional accountability remains fragmented. The real challenge is not generating explanations. The challenge is establishing a shared enterprise definition of what constitutes an acceptable explanation and operationalizing that definition consistently across the organization. As AI adoption expands, enterprise maturity will increasingly be measured by the quality of decision systems rather than the sophistication of models. The organizations that lead the next phase of AI transformation will build three foundational capabilities. First, traceability infrastructure that captures every important decision event and preserves it in a retrievable format. Second, accountability architecture that clearly identifies ownership and responsibility throughout the decision lifecycle. Third, evidence retention mechanisms that preserve explanations, approvals, overrides, and escalation records by default. Together, these capabilities create what I would describe as auditable decision systems. The focus shifts away from proving that an algorithm performed accurately. Instead, the focus becomes proving that the institution governed the decision responsibly. That distinction may ultimately define the difference between successful AI transformation and sustained governance risk. As enterprise AI matures, a new strategic divide is beginning to emerge. Some organizations continue treating explainability as a technical feature attached to individual models. Others are elevating explainability into a core architectural discipline. The difference is profound. Organizations in the first category often struggle with fragmented accountability, inconsistent governance practices, and costly post-incident investigations. Organizations in the second category build durable institutional capabilities that support transparency, regulatory readiness, and operational resilience. Ultimately, the winners of the next phase of enterprise AI will not necessarily be those with the most sophisticated algorithms. They will be the organizations capable of creating auditable, traceable, and defensible decision systems at scale. Because in the AI era, competitive advantage will increasingly depend not only on intelligence, but on trust. And trust, ultimately, is an architectural outcome.